Put your pencils down and pick up your colored pen. But first, let me say good afternoon. I hope you are all doing well today. I hope you've had an excellent weekend. It is good to see everybody. Let's get to work. So, today's warm-up, different style of question. Similar to the multiple select, although a bit different. So, I am looking for one of three answers. I'm looking for none, one, or infinitely many. So when I call on you for a particular letter, A, B, C, D, or E, you're just going to give me none, one, or infinitely many. So let's start with A. And here we go. Student number 15 and 13. What do you say? You both think it's 1? It is 1. Part B. I've got student 19 and 6. Nope, check that. Student number 19 and 2. Student number 2. So we have a disagreement. Infinitely many. Part C, I've got student number 10 and student number 8. Student number 10 is not here. I got student number 8 and student number 1. You both think that there is one solution? There is one solution. Part D, I've got student 7 and student 12. You both think it's 1? It is 1. And finally, part E. I've got student 20 and student 11. Student 16, what do you say? Student 16 is not here. Student 4, what do you say? It is none. Today's warm-up is multi-purpose. It is a review of an important idea or several important ideas from the past, and it is critical for today. So it's an excellent warm-up. And I must say that I'm very, very impressed with my students. Very impressed that it seemed like many of you were able to come up with a strategy for how to figure this out. So let's talk about strategy. What did you do? What did you do? We'll start with Mark and then Deja. What did you do, Mark?
I did substitution and elimination.
Okay, so let's just take part A. What did you do for part A?
For part A, I did substitution.
You used substitution, and you were able to get one solution. So let me pause here, and then I'm going to go to Deja. Please understand that when we say one solution, that means that there's one ordered pair that makes it true. So what that means is A, C, and D each had one ordered pair because it represents a system where the lines are crossing. Right? Okay. Deja. You did elimination for part A. Good. And you were able to get one solution? Very good. Did you also do elimination for part B? And you were able to figure out that it was infinitely many? Okay. What was your result when you did elimination? Okay. So that was excellent. So you multiply the top one by -2. Great idea. But then what happened is everything canceled out. But this is what you ended up with. You ended up with 0 equals 0. Is that correct? So if you get a true statement, that means infinitely many. If you get a false statement, that means no solution. There's also another way to tell. In fact, I could do part B without doing anything. If one equation is a multiple of the other, then they're actually the same equation. For example, what if we took the negative away from here and just multiplied the top one by 2. Everyone go ahead and do that. Multiply the top equation by 2. Someone tell me what you get? Because most of you are doing it mentally, so I'm assuming you can do that mentally. Ethan, what do you get? Do you see that anywhere else? Yeah. It's the same equation again. You get the same equation twice. Well, now you have to picture the graph of that. One equation is going to be a line. If the second one is the exact same equation, then it's the exact same line. 2 lines lying on top of each other. Lying on top of each other means infinitely many because we're talking about where the lines cross. So, any questions about that? Did anyone use a method other than substitution or elimination? Anyone use another method? There is another method out there that would be very, very effective for this particular question. If you don't need the actual solutions and you just need to know how many there are, if you put both equations in slope-intercept form, you'll instantly be able to tell. Because, let's see, where's an easy one that I can do? Well, this one would be, let's see, this would be y equals 2x, nope, negative 2x. No, 2x plus 1. And this one would be y equals negative 1/5 x plus 6. Different slopes, you automatically know that they're going to intersect. But what we would find here is that they were both exactly the same line. And what we would find here is what? What would we see if we converted both of these to slope-intercept form? You don't know what you would see? Okay, go ahead. Convert both of them to slope-intercept form using your colored pen right now. Part E, convert both of them to slope-intercept form. Give me a thumbs up if you got it. See, most of you still working. Okay, keep going. Doing fine. Make sure you put those fractions in simplest form. You won't see it unless you put those fractions in simplest form. You won't see what you need to see. Fractions always go in simplest form. The teacher doesn't even need to tell you that. You just do it. Emily, you got it, or you had a question? Okay. I'll come to you first. Got it? Good. take a few seconds. All right, Emily, just tell me this. What's the slope of the first equation?
4 over 6.
Okay, now tell me really what the slope is.
2 over 3.
Thank you. 2/3. Let me do that a little bit better. 2/3. Now tell me the slope of the second equation. 2/3. If you don't put fractions in simplest form, you can't see that. So now we already know, just from that, that one of two things is going to happen. One of two things is going to happen. Give me one of them. What's one of the possibilities when the slopes are the same? One of the possibilities. Milan? Say it a little louder. Very good. They might be parallel. What's the other possibility? There's one other possibility, and we already talked about it. Diane? No, if they have the same slope, they're never going to cross. Well, no, I'm sorry, I take it back. Sort of. But I think you're missaying it, so we've got to be careful. Christian? Yeah, it's going to be the same line. So it's either going to be parallel or on top of each other. So now we need to look at the y-intercept. So Emily, what's the y-intercept of the first one?
15.
No, it's not 15. You didn't quite finish. Remember, you have to divide everything. Deja, could you? It comes out to 2.5, correct. And then what is the y-intercept of the second equation? Ethan?
3/4.
Is it 3/4? Let's see. 3/4? 4/3. Big difference. But, so now tell me, what is the result? Milan, what's the result? Parallel lines. If the y-intercepts were exactly the same, then they would be the same line, like Christian said. But these come out to be parallel. Same slope, different y-intercept, they're parallel lines. And that is why we get no solution. Because the lines never cross. So all these ideas are interconnected. Very, very important ideas. And you guys did a good job. Emily, did you find your mistake?
Yeah.
Okay, good. Aaron.
How do you find the C, the intercept? The y. 2.5.
You're rewriting this equation. Okay? This goes way back. First, you have to subtract 4x from both sides. So we've got negative 6y equals negative 4x plus 15. Now divide everything by negative 6. Divide by negative 6, divide by negative 6, divide by negative 6. So I'm sorry, this should be minus 2.5. So that's my mistake. I apologize. I went too quickly. So that should be minus 2.5. But either way, the result is still the same. So this cancels out. And this becomes 2/3, and that becomes negative 2.5. Okay? Is it coming back to you now? Good. And that was that one. Any other comments or questions? Good. So there's a lot going on. I mean, technically that was one question, but clearly that was a lot more than just one question. You guys did a great job. So again, you've already titled today's lesson, Lesson 8-10. Today we're going to be exploring something called nonlinear systems, which made today's warm-up doubly important, because today's warm-up was all about linear systems. Linear systems are systems made up of two lines. Today we're going to explore systems that are not just two lines, that are a line and something else. I like this lesson a lot. I like the concept a lot, because it's one of these ideas that forces you to use half of the ideas you've learned all year, all in one shot. You're literally going to be pulling skills and ideas from the beginning of the year, a quarter of the way through the year, halfway through the year, and all the way to now. So it's great because it pulls from so many different areas. It forces you to really think about all these different things you've learned. You're going to love it and you're going to hate it. You're going to love it for the same reason that it's a great way for you to demonstrate how much you've learned. And you're going to see what an amazing transformation you've gone through since the beginning of the year till now. You think about what you walked in this room knowing and what you're able to do now. Dramatic. You're going to hate it because it's challenging and it's difficult. But that's not really a reason to hate something. It's just a reason to really take notice of having to persevere. So let's get a little bit more specific. What am I talking about when I say a nonlinear system? Well, recall that a linear system is two lines. Here was the important part. A solution to a system is an ordered pair that makes both equations true. A solution is an ordered pair. The points where the lines cross are the solutions. That's true no matter what. So, if we talk about a nonlinear system is going to be a system made up of maybe a line, but then something else. Could be quadratic, could be cubic, could be quintic, could be something else. For example, today we're going to explore what happens when we have one line and one parabola, one linear equation and one quadratic equation. Here are some examples. Here are linear systems. This is what you explored during today's warm-up. That's a line, that's a line. That's a linear system. That's a line, that's a line, that's a linear system. Nonlinear systems. That's a parabola, that's a line, that's a nonlinear system. That's a parabola, that's a line, that's a nonlinear system. Anyone have any questions about that? So now let's look at what could happen. Here's what can happen. You've seen this before. You just saw it during today's warm-up. Something like it. We can now have one solution where the line touches the parabola in one specific spot. We could have no solution where the line and the parabola never cross. Or we could have two solutions where the line and parabola cross in two specific locations. And so today we're going to learn how to find those solutions. One way is to graph both of them. Remember the process of graphing a quadratic? Make a table of values, draw it. Remember the process of graphing a line? Now we're going to do both. Yeah, but we're not going to do that. Because we have methods that we've learned that we can use to solve systems. And those methods that you learned not only work for linear systems, but they work for nonlinear systems. The methods you learned, most of you just used. Mark, what methods did you say you used during the warm-up?
Substitution and elimination.
Substitution and elimination. The three methods we have are graphing, substitution, and elimination. Graphing is a very impractical approach, so we're going to be focusing on substitution and elimination. Anyone have any questions? All right, no questions? So let's jump in. So the first system we're going to attempt is y equals x squared minus x minus 5 and y equals negative 3x plus 3. That is the system. The question is, what are the solutions to that system if there are any? We have three possibilities. Either there's no solution, there's one solution, or there are two solutions. We're going to get ourselves set up for success. We are trying to see if there are two ordered pairs that will make this system true. In other words, what ordered pairs would work for the top equation and the bottom one? If we wanted to, we could do guess and check. We could do guess and check. We could just try 1, plug in a 1, see what the value came out to, and just keep going until we found the right ordered pairs. The problem is that would probably take forever. It would probably take the entire block just to do one. Not very practical. So instead we have this method called substitution. What substitution allows you to do is once you have it set up right, is you get to take the equations and kind of combine them together. Because here's what we have. We have y equals this whole expression, and we have y equals that whole expression. Y is equal to both of them. So, and here's how I said this months ago when you learned linear systems. Y and this expression are now interchangeable, right? Remember me saying that? They're interchangeable. That means that anywhere you see a y, you can take it out and replace it with negative 3x plus 3. So we can now take this expression and replace that y with it. Because that's the whole point of substitution, is to get rid of one of the variables. Once we get rid of one of the variables, we can solve. So here's what we end up with when we do that substitution. We end up with negative 3x plus 3 equals x squared minus x minus 5. We just took a system and combined things into one quadratic equation. This is now a quadratic equation because the highest exponent is 2. So now we have to solve it like a quadratic equation. Right? It started out as a nonlinear system, but we did something to manipulate it so that it turned into a quadratic, and now we can solve it like a quadratic. Most of the methods you learned for quadratics involved getting the quadratic all on one side and a 0 on the other. So what we would like at this point is, instead of this being here, we would like a 0 on this side, and we would like the quadratic on that side. So how can we do that? How can we get the negative 3x to jump from the left to the right? Now we're talking about something you learned way back at the beginning of the year. Kianis? You said it perfectly. Add 3x to both sides, but watch what I'm going to do. I'm going to put the plus 3x underneath this one, because those are like terms. And now we're going to add. So we now have 3 equals x squared plus 2x minus 5. But now I need to get rid of that 3. So how do I get rid of that 3? Emily?
Subtract 3 on both sides.
Beautiful. Subtract 3 on both sides. This disappears, and that's when we get our 0 equals x squared plus 2x minus 8. Now we have a quadratic that we can solve, hopefully. Here is where you are now using all of the tools that you've developed over the past month and a half. We now have to solve a quadratic. Factoring, using square roots, the quadratic formula. We could graph it if we wanted to do that. So which method do you think we could use to solve this? Something should immediately be popped. Okay, let me say it a different way. Put your hands down. Go ahead and set this up to be solved. Take a minute. Go. Do it. You shouldn't be looking quizzically, because if you look at the warm-up from the last lesson, you had to do it 6 different times. Okay, now stop. What method are you doing? Don't finish it. What are you doing, Angela? You're factoring. You should be doing this. You could do the quadratic formula if you wanted to, but you'd be just spending extra time. Did anyone already figure out what the two factors are? Go ahead, Angela. You're on a roll.
X minus 2 and then x plus 4.
X minus 2 times x plus 4. That multiplies to -8, and that adds to +2. Very good. So now we've got the factors. How do we now solve this? How do we solve this, Aaron?
Put 0 next to the x minus 2 like that.
This is called a factor.
Well, yeah, grab one factor and put it equal to 0.
Beautiful. So we take x minus 2 and set it equal to 0. What about this factor?
Oh, x plus 4 equals 0.
Okay, so do the same thing again. X plus 4 equals 0. Solve both of those. X equals what? X equals what? Isabella?
2 and -4.
Shannon, you agree? 2 and -4. So we get x equals 2 and -4. Well, not quite done, but we're almost done. We just found the x coordinates of both solutions. This is why I set these up. Because now we know those are going to go right there. One's going to be 2 comma something, and one's going to be -4 comma something. How do we get the y coordinates? How do we get the y coordinates for each of those? Milan? Good. Where should we plug it in? Well, let's do a quick test. Let's have everyone from Tristan on back. You're going to use the first equation. And everyone from Isabel's row on back, you're going to use the second one. Did someone suck their teeth?
I did.
No? You know I'm looking at you first then, right?
I did, but I actually.
Okay. But it was actually a serious question, is why did someone suck their teeth? It's an important question. Because I made all of you use the first equation. What's wrong with that? Which one did you want to use? Go ahead, Milan. Why? Oh. Because guess what? You're going to get the same answer either way. You don't have to plug it into both of them. You're going to plug it into one of them. And the reason that someone sucked their teeth over here, I don't want to do that one. Because you want to use this one because it's easier. Probably. So go ahead. Plug in the 2 here and you get the y value. Plug in the -4 here, get the y value. For most of you, that's mental math. Go. Don't use your calculator. I said for most of you, it's mental math. So, can someone give me the first solution? What's the first solution? Sean? So the solution is 2 comma -3. And what's the second solution? Second solution. Deja? What is it? -4 comma 15. So, 2 solutions. So let's analyze what we did briefly so we can make sure we understand what happened. We started out with this system. But then we turned that into this by using substitution. From here to here, we used skills from the beginning of the year to rewrite an equation. That's way back at the beginning of the year, rewriting an equation. From here to here, we use skills from recently, where you learned how to solve a quadratic. And this skill right here, you learned like a month and a half ago, factoring. So we are using skills and ideas from all over the place. And you did it. Took a while, but you did it. And you should feel proud of what you did. Does anyone have any questions about what we did? All right, so we're going to do one more. And then we're going to give you an opportunity to prove how well you're understanding. So, part B is set up perfectly for substitution because we've got y equals and y equals. That right away tells you it's great for substitution. So we can take the same approach where we take this and replace the y with it, interchangeably. And so we end up with negative 3x plus 4 equals 3x squared minus 3x plus 1. Now we need to rewrite it. Go ahead, Kianos. Add 3x to both sides. This time that cancels out. We're left with 4 equals 3x squared, but then that cancels out also. Plus 1. Subtract 4 from both sides. You guys already know this. That cancels out. We get our 0 equals 3x squared minus 3. Now, what method have you... So I'm sorry, before I continue, does anyone have any questions on how we got to here? So now it's a quadratic equation and we need to solve it as one. Here are the methods we know. We know graphing, we know factoring, we know using square roots, and we know the quadratic formula. Which method is going to work really well with this one? Got 2 people who know? Okay, put your hands down. You got 30 seconds to discuss with your team which method you should use. Go. All right, Shannon, what were you going to say before? What were you going to say, Angela? Square roots is going to work really well when there's no middle term. No middle term, square roots. And watch, it's going to be super easy. Ready? Add 3 to both sides. So now we're kind of going backwards a little bit. Add 3 to both sides. That will disappear, and we get 3 equals 3x squared. But to take a square root, we need to get rid of that 3. So divide by 3 and divide by 3. And we get x squared equals 1. And here's the technique that you learned. Take the square root of both sides. So, take the square root of that, take the square root of that. And we will get x equals what? What will x equal? Deon? You got fired. Why did he get fired? What was he supposed to say? Ethan, what was he supposed to say? Plus or minus 1. There are two solutions when you take the square root. Plus or minus 1. Diane, I was kidding. You didn't get fired. So, because positive 1 is a solution and negative 1 is a solution. So now, we need the solutions to the nonlinear system. One of the x values is going to be 1. One of the x values is negative 1. So now, plug in and get your y values. If you want, use the first equation. Or just use this. Thank you for sucking your teeth. Good. If you are operating at a high level, use the second one. Mental math. Put in a 1. That's a negative 3 plus 4. You get 1. Mental math. Plug in a negative 1. That's positive 3 plus 4 is 7. And the two solutions to this nonlinear system are 1, 1 and negative 1, 7. Does anyone have any questions on how we went about this? You got to know your techniques. You got to know your tools. You got to know what you are allowed to do. Are there any questions? All right, prove it. Checkpoint number 1. Solve this system by substitution. Got 5 minutes on the clock. If you finish before the bell rings, compare your answers with your teammates. Okay, so I guess a little too much time, but that's okay. I want to make sure everyone had a chance. Let's see how we did. I got students 17, 8, 2, 6, and 4. 6 is not here. So I got 17, 8, 2, and 4. 17.
1, 4, and 4, 5.
Student number 8.
Oh, 1, 2, and 4, 5. Sorry.
4, 5, and 1, 2.
So it sounds like you agree. Student number 2.
1, 2, and 4, 5.
We got 3 people who agree. Student number 4.
1, 2, and 4, 5.
So we got 1, 2, and 4, 5. Now, first of all, give me a thumbs up if you got it right. Wow, it's a pretty high rate of success. Impressive. Put your thumbs down. So, let me rewind them. These were all set up the same way. They were all set up perfectly for substitution. And that certainly will not be the case all the time. So what if it's not set up? So then, if you want, if we would like, we can use elimination. I'm going to show you how to do it. So far, my experience has been that I've used substitution quite a bit more than elimination. But elimination is a great technique, and we want to make sure we know how it works. It's a little bit different, tiny bit different than with a linear equation.
Bless you.
You can. So you can do substitution? Absolutely. Absolutely. But just go with me on elimination. Now, to do elimination, we can't get it set up. For example, let me go way back to today's warm-up. I can't get it set up like these because we have an x squared term that doesn't quite fit into the pattern. So it's going to be a little bit different at the very least. So let's see what is different. Well, I need to line them up. And what I'm trying to do is eliminate one of the variables, so I want one variable to line up on one side of the equation. You'll notice that I have a y on the left and I have a y on the left. They have to be on the same side, otherwise it won't work. So all we have to do is realign this. So I'm going to rewrite this whole thing over here. 3x minus 7 equals 1. Now I'm going to write the second equation, but I'm going to put the y
Minus 7?
minus 1, exactly. Equals 1. Thank you. So I'm going to take the second equation and I'm going to line it up so that the y is underneath this negative y. So the y is going to go here, the equal sign is going to line up, and then we've got x squared plus 4x, and there's the minus 7. Now it's set up for elimination. We're trying to eliminate variables. Remember how elimination works. You add down. So what we end up doing is we add down like in elementary school in columns. Right? But you have to make sure you're adding like terms with like terms. So see this 1 that was left over here? That doesn't get added to this because those aren't like terms. That gets added to this over here because that's the column that it's really in. So now we add down in columns. 3x and nothing is 3x. Negative y and y cancel each other out. That was the whole point. Equals x squared plus 4x minus 6 because we're adding negative 7 and positive 1. That was the elimination. Now, we have the similar situation to what we had before, which is now we have a quadratic equation that needs to be solved. So solve it. Get the 3x to jump over to the right-hand side. So we'll subtract 3x. That will disappear, and that's where we get our 0. Equals x squared plus x minus 6. Does anyone have, I'm going to pause here, does anyone have any questions on how we got to here? Set it up for elimination, got those lined up, added down, and then rewrote the equation. Now we have a quadratic and your spidey sense should be tingling. Spidey sense should be tingling because you should be looking at this going, oh, I know, the factors are so easy. You should be thinking, this is easy to factor. So what are the two factors? What are the two factors? Diane? Very good. X plus 3 times x minus 2. Let's make sure we're clear. A factor is x plus 3. 3 is not a factor. X plus 3 is the factor. And as Aaron reminded us earlier, we now need to set these up to solve. X plus 3 equals 0. X minus 2 equals 0. And solve both of those. X equals negative 3 and positive 2. And now we're almost done. Ordered pair, ordered pair. -3 comma something, 2 comma something. This time you might want to use the second equation. The first one's a little bit messy. It's up to you. Nine, -12, and -7. That'll be a -10. And then 4, 8 is 12, minus 7 is 5. Second equation is not so bad. And we get 2 solutions. Any questions about that? Any concerns? Okay, put your pencils down, please, so that this next example can be used just to illustrate one point. But remember, when pencils are down, you've got double focus up here. So I would like to demonstrate elimination again. So I'm going to do the same thing I did before. I'm going to line these up. So this time the quadratic is up top, so I'm going to put y equals 2x squared plus x minus 1, and I'm going to line up the y's. I'm going to try and eliminate those. X minus 2y equals 6. But the y's are not opposites. This is a -2y, and that's a 1y. But you learned what to do about that. What can we do to get the top equation so that the y becomes the opposite of the bottom one? What can we do there, Kiana?
Multiply the whole top equation by 2.
I love the way you said that, because you said multiply the whole equation. So we can multiply the whole top equation by 2. And so this will become 2y equals 4x squared plus 2x minus 2. I'm going to rewrite that underneath. 2y equals 4x squared plus 2x minus 2. And now I don't need this at all. I'm done rewriting that. And now my system is written down here. And now I'm ready to eliminate. So now I can add down. That will cancel out, and I'm left with x equals 4x squared plus 2x plus 4. And then I can proceed. So my purpose here was to, remind us of this, that you can multiply an equation at the whole thing by any number that you want, at any time that you want. Any questions about that? Good. Checkpoint number 2. I would like you to try and solve it using elimination. Try using elimination. 4 minutes on the clock. 5 minutes was too much.
That's great.
Tristan, I can't believe it. I was gonna ask if she could in water. Like, I got saying that she was like,
Slap me in there.
All right. Seem like we're gaining some confidence. Let's see how we did this time. What did you get? I got student 11, 14, 4, and 20. Student number 11.
-1, -4, and 3.
Okay, student number 14.
3, 4, and -1, -4.
Okay, student number 4.
-1, -4, and 3, 4.
And student number 20.
3, 4, and -1,
It seems like everybody agreed. 3, 4, and -1, -4. Give me a thumbs up if you were able to get that. Put your thumbs down. Impressive. Very impressive. And so let's finish out by exploring one last scenario, the most important. And you guys have done a great job. So you're near the finish line. I know that energy at this point is tough to come by. But I ask you to just sit up tall, and you guys are going to do great. And I promise you it's not as bad as you think. But do not copy the text. Read the question to yourself. Now, an elevator does not follow a vertical motion model because it's not affected by gravity. It's a mechanical system that's controlled by an engine. So the force that's pushing it up and down is controlling the speed at which it moves and everything about it. So there's nothing unusual. It's a very simple way to figure out where an elevator is going to be. Its height is going to be based on the time, and that's it. But a ball being dropped, follows a vertical motion model. It's actually a dropped object model, and we've seen this before, the middle term disappears because there's no vertical velocity, or vertical velocity is 0. So the question is, at what point will the ball and the elevator meet? At what point will they be at the same height? The elevator is going up, and the ball is coming down. At what point will they be at the exact same height? This is what a nonlinear system is for. So we have h equals 8t, and we also have h is equal to -16t squared plus 120. This is set up perfectly for one of the methods. Which method immediately? Milan? Yeah, absolutely. Because h and 8t are interchangeable, we can take that 8t and plug it in right there, or we could do the other way, it doesn't really matter. And so we get 8t equals -16t squared plus 120. Now set up the quadratic. Subtract 8t from both sides. That will disappear and we'll get our 0 equals -16t squared minus 8t plus 120. Anyone have any questions on how we got to this point right here, which was the critical point? So what technique do you want to use to solve? You want to use the quadratic formula? Should we use the quadratic formula with gigantic numbers like -16 and 120? And go ahead. Very good. Outstanding catch right there. Greatest common factor is definitely going to make our lives easier. Bless you. Anyone know what the greatest common factor is? Go ahead, Milan.
2.
Well, you had a good instinct that we want a negative because we want to get rid of that negative right there. But there's another factor that they have in common other than 2. -8 is 120 divisible by 8?
Yep, it's 15.
Ah, yeah, there you go. So -8, very good. And so now rewrite the quadratic factor. -8 times 2, -8 times 1, and -8 times -15. And now it's quite a bit easier. It's not great, but it's quite a bit easier. Anyone have any questions on how we got to that point? Well, we're still not done. We still have to get the solutions. We still need to figure out what t equals, so we're here. What should we do at this point? You have choices. What are the choices that will work? Angel? We could do the trick. What's another choice? Quadratic formula. Good, so let's have everyone in Angela's section try the trick. Everyone in Diane's section, you're doing the quadratic formula. Go! Well, you don't know which one's going to be easier. What if the trick doesn't work?
Oh,
Oh, that's more trick. Okay.
so how do you do it again?
Go!
I knew that. I was gonna say.
No, you have it in your lesson. All right, I'll put it up. You should know it at this point. Not going to spend 10 minutes remembering it when you're supposed to be using it. Does the trick work?
If I did it right, I think it did.
I don't know. I did it with the quadratic formula. Let's see. -30.
Oh, what did you
A times C.
Oh.
-30.
Yeah, whatever. It's 30. Negative 5 + 6. 15. Yeah.
Anyone got the trick? Done? Good, I saw it. Yep, you got it.
Okay, then I have negative, third, I have to think to be -5, 6 over 2.
Negative 5, 6
Or
over 2.
-5,
Positive 2. Negative 8.
I mean, negative 6.
Negative 5 over 2.
And then
Positive
6 over
something.
2. Yeah, I got that. And then simplify. I got 3 over 1.
take a few seconds to finish up. All right, we got t equals what? What are the two solutions? I've got Angela, Diane, and then Aaron. Angela, what'd you get?
I got -3 and 2.5.
So you got -3 and 2.5. Diane, what'd you get?
I got
-1/3 and 2/5. You made a mistake somewhere.
2t plus
Aaron, what did you get?
I got
4
3 and
and t
-5.
No, you didn't finish. You're getting confused between factors and solutions. You didn't finish. So these are the two solutions, but they are not the solutions to the question. The question says, what's the time that it will take for the ball in the elevator to reach the same height? So we need to now interpret this. So someone tell me, at what point, how much time will have passed when the ball and the elevator are at the same height? I understand that some of you messed up, whatever. These are the correct solutions. All I can do is help you individually to find out where you made the mistake. But now from here, let's work together. -3, 2.5. Now someone tell me, how much time will it take for the ball in the elevator to meet? Emily?
2.5.
Why not -3? Yeah, there's no such thing as negative time. So of course we disregard the -3, and the answer is 2.5 seconds. 2.5 seconds. All right. You guys did very well with that. Here is your homework. It's page 485, you're doing numbers 3 through 10. And page 486, you're doing numbers 1 through 4. And I need to modify this because you should now be on sections 5 and 6.